If you are a Sec 3 G3 math student, indices is one of those topics that will definitely come out for your WA, and I want to help you make sure that you know how to solve these type of simple laws of indices questions. So if you take a look at this question over here, this question actually incorporates almost all of your laws of indices that you learn in school. And one of the things that I teach my students at my Math Tuition Center, A1 Math Academy, is to be able to break down the steps to tackling laws of indices questions. And the golden principle here is to always start from outside and work your way inwards. So what I mean by this is, if we look at the whole expression over here, right, we see that there's a square outside and a power 3 outside. And what we're going to do is that we're going to put the powers inside first, right? We don't do anything else. But before we even put the powers inside, we can make our life a little bit easier by changing everything to power form first. And that's exactly what we're going to do. So if you're going to change this to power form, then square root x is just x to the power of half, right? And then this is just 2y. And then put the square outside. Now, same thing for the other one. This one might seem a little bit daunting, but actually it's pretty simple, because what this is just root x to the power of half, right? And then this is y to the power negative 1, 3. And then you see that there's another root over here, which means that I can repeat the same step one more time. And this actually gives me x to the power of half, followed by half outside, y negative 1 to the power of 3, right? And then I can just bring down whatever I wrote earlier on, which is x half over 2y squared. And then now we're going to put the powers inside. So putting the power 2 inside and the power 3 inside, the power 2 goes to every single term inside, the power 3 goes to every single term inside. And what I end up with is x to the power of half times 2 over 2 square y squared, right? One of the mistakes that I see is that people always take 2 times 2 instead of 2 to the power of 2, right? Even though both gives you 4, you must always make sure indices is always in terms of powers. And then now we have divide. Now it's x to the power of half times 3 over y to the power of negative 1 times 3, right? And simplifying the powers over here, we get x to the power 1, 4y squared divided by x to the power of 3/4 over y to the power of negative 3. And now over here, we see that there's a divide fraction, which means that we can flip this to give us y to the power of negative 3 on top over x 3 over 4, right? And you realize that there's a negative power at the top. And this is a shortcut that I teach all my students. If you see a negative power on top, it means that you can just bring the y down to the denominator. So you end up with 1 over y cubed, x to the power 3/4 equals to x over 4y squared. And therefore, to combine these two answers, I see that x to the power 1 on top and x to the power 3/4 below, which means that I can strike this out over here, and that gives me 1 minus 3/4 on top, which therefore gives me x to the power of 1/4 over 4y. Here there's a square, there's a cube. If I combine these two, am times an gives me am plus n. Eventually, this gives me 2 plus 3, which is basically to the power of 5. And therefore, this is the final answer to this very, very simple indices question. So as you can see over here, indices might seem a little bit daunting at the start, but if you break things down using a simpler framework, it will always give you the correct answer. And if you're still struggling with applying your laws of indices and you need more practice, watch this video next for a solution. So if you're still struggling with your basic Emath concepts, or you already understand your basic Emath concepts, but you want more practice questions, more examples of the type of questions that usually come out in your exam, what I've done is that over the past 3 years, ever since I started tutoring, I've been creating this huge resource called the Library of A1 Math Academy, where I literally reteach you the entire syllabus from scratch. And not only that, but I expose you to all the different type of questions that can come out for every single chapter and give you the solution to every single question. So for example, if we take a look at this one Emath chapter in Sec 3 called Indices, right? I literally film every single chapter from Sec 1 to Sec 4, right? So the whole entire syllabus. And if you go under syllabus over here, you see that I have broken down every chapter into 4 modular portions. So the first one is where you can download all of my handwritten notes, my solutions. You can just click on the PDF and download it. The second portion will actually bring you to the part where I reteach you the entire chapter from scratch, starting with all of the basic fundamental concepts. So if you just click on any fundamental concept, let's say the idea of laws of indices, right? Under the laws of indices over here, there's quite a few laws, right? I go into each law very, very in depth, as you can see on the screen over here. Every single law, I list it down for you nicely, and I make sure to go super in depth to show you how it's actually being applied. Not only that, but I also go through all the usual exam questions that you will see, right? So for example, if we click on just here, right, the first question type, I give a video solution to every single question, and you can see I also give the PDF answer to every single question, right? So when you get your hands on this resource, you are really getting the full support, the full fledged of resources to support you throughout your whole Emath journey and to help you score the A1, even if you don't attend my classes physically in person. So if you like more information about this library and how you can get your hands on it, just WhatsApp the number on the screen over here, and I'll send you more details over there. And I look forward to seeing you on WhatsApp over here.